In this video, we'll see how to configure the gateway for Azure IoT Hub and test communication both from and to the gateway. Before we proceed, there are a few things we need to consider. From the Azure portal side, an IoT Hub should already be defined. As for the gateway, it must also be defined as a device inside the IoT Hub. Keep in mind that when defining the device used to represent the gateway, its device ID must match the client ID defined in Maps. We'll use a Cloud Shell to generate a SAS token, which is a time-limited credential that allows the gateway to connect with the IoT Hub. But first, let's configure the project in Maps. The gateway should already be connected to the network. We'll start by creating an MQTT project first. Then we'll connect to the gateway using any of the available connection types. Returning to the general configuration section, it is good practice to enable time configuration and define an NTP server, as the gateway's time accuracy is critical to certificate validation. We should also update the password now, or otherwise we'll be prompted to do so when we save the project. In the brand-specific configuration section, enable one unit. This allows us to have access to the signals required to test the communication later. Moving on to the MQTT 3.1.1 part of the configuration section, go to Connection and select Azure IoT Hub as the Cloud Platform template. As you can see, with this selection, some features are locked and others are removed straight away. This is done to match the specific requirements of the Azure IoT Hub platform. For the client ID, we recommend using the gateway's MAC address to ensure its uniqueness. To get the gateway's MAC address, press the Use MAC GW button. Remember that this value and the device ID used when defining the gateway as a device in the Azure IoT Hub must be the same. The host value can be found in the overview of the Azure IoT Hub. Copy the hostname and paste it in Maps. The port value is the standard one for secure MQTT communication, 8883. IT departments may block this port by default. If so, ask your IT team to enable inbound and outbound traffic through TCP port 8883 to ensure the system functions properly. All that's left here is to enable authentication to enter the credentials. The username string follows a predefined structure. First, the hostname, followed by a slash and the device ID, followed by a second slash and a fixed string with the API version, as shown here. The password corresponds to the previously mentioned SAS token. We'll generate it via the Cloud Shell we've seen before. For this, we need an IoT Hub connection string, which can be found in the Shared Access Policies settings. As you can see, you may not have the necessary permissions to view the Shared Access Policies. If so, you will need to ask someone who has them for the IoT Hub connection string. It's very important to keep this connection string private, since anyone who has it can interact with your IoT Hub. With the connection string at hand, enter this command in the Cloud Shell. AZ IoT Hub generate SAS token, followed by two parameters. -D, followed by the device ID, and -L, followed by the aforementioned connection string. If this is the first time generating a SAS token with this command, you might be asked to install an extension. In that case, simply follow the instructions displayed in the Cloud Shell. After a few seconds, the SAS token should be displayed. Copy it and paste it into the password field. We still need one final step to connect with Azure IoT Hub, and that is to add the TLS certificate files. To do so, go to the Security section, enable SSL TLS, and attach the corresponding certificates. The current Microsoft recommendation is to add the DigiCert Global Root G2 and the Microsoft RSA Root Certificate Authority 2017 certificates. And we're done. Now all that's left is to save the project and send it to the gateway. After reconnecting, we'll test the connection via the Diagnostic tab. Okay, we are once again connected to the gateway. Communication between the gateway and the IoT Hub is bidirectional. The signals sent by the gateway to the IoT Hub are listed in the Publish section, and the signals received by the gateway from the IoT Hub are listed in the Subscribe section. We'll send a signal first. We can do that from the Diagnostic tab. To get all the information we need, we should enable both comms and debug in the MQTT viewer. This will also allow us to see if there's any problem establishing a connection. No messages should mean that we're good. To proceed, we could use any status signal. Let's simulate a unit being turned on by entering a value of 1 in the status on-off signal. As we can see in the MQTT viewer, the signal has been sent. We're halfway there. Now, we'll check that messages sent from the IoT Hub are correctly received by the gateway. For this, we'll go to the device representing the gateway in the IoT Hub and use the Message to Device function. To send a message, we need to specify its payload and also its property bag, which is used by the gateway to associate the payload with the corresponding unit and signal. For the payload, we must use the same structure as shown in Maps. For this example, we'll send a temperature command. First, locate the setTempCMD signal in the message payload text area of the Subscribe section and copy its payload. Then paste it in the message body of the Message to Device function, changing the value to, for example, 20 degrees. The property bag corresponds to the substring after device bound, and it includes both the unit ID and the metric name. This information must be entered in the Message to Device function as user-defined properties using the provided key-value pair format. Don't forget to replace the placeholder for the unit ID with the correct value, which in this case is 1. That should be all. Now press the Send Message button. According to the IoT Hub, the message has been sent. Now let's check the Maps Diagnostic section to confirm its reception. And here it is. We can see the related information in the MQTT viewer, and most importantly, the updated value in the signals viewer.